So this question, we'll try to solve it first using laws of motion. So we have an object of mass m. This is object of mass m. Smooth horizontal plane, which means friction is which means coefficient of friction is equal to 0, right? Force is 2 Newton. There is a minor mistake, is angle theta, which is equal to kx. Okay, varies as kx, varies as kx. And x is the distance covered by the object from its initial position. So I'll mark this as initial position. Say this is x equal to 0, and this is at x equal to x. Okay, at x equal to x. The initial velocity is 0, so this is u is equal to 0, and the final velocity is v. Okay, so these two terms are really important: 0 to x and 0 to v. Okay, so x is varying from 0 to x, and velocity is varying from 0 to v. Now, while we approach a question in laws of motion, what is the well, this can't be generalized, but in most of the cases, we can solve any question in laws of motion by using these 4 steps. So visualizing first, visualization, choosing a frame of reference. I will choose the frame of reference that the observer is standing in an inertial frame. Inertial frame. Drawing the free body diagram. I got the free body diagram here, and then sigma fx, sigma fy, and then solve. So we will go through the free body diagram and sigma fx fy part. So this is the free body diagram over here, right? This force F is equal to 2 Newton can be resolved into two components. One, the horizontal component F cos theta, and the vertical component F sin theta. Now, since there is no motion along the x direction, right? Since there is no motion along the y direction, why? Because you see, this object is restricted only along the x-axis. This is moving only along the x-axis. So there is no upward movement of this block. So we can therefore say that displacement along y direction is equal to 0. And if you differentiate this equation, what do you get? What we get is velocity along y direction is equal to 0, and therefore acceleration along y direction is equal to 0. And if acceleration along y direction is equal to 0, if you multiply this by m, what do you get? M into ay is equal to 0. And what is m into ay? M into ay is sigma fy, and therefore what do we have? Sigma fy is equal to 0. So that is first condition. Now if we apply sigma fx, what is sigma fx is equal to? Since there is a definite motion along the x direction, we can write that sigma fx is equal to m into ax. What is ax? See, I have made a small algebraic manipulation here with respect to ax. I can write a is equal to dv by dt, right? And dv by dt can further be written as dv by dx into dx by dt. Okay. And what is dx by dt? Dx by dt is velocity again. And what is dv by dx? It remains dv by dx as such. So a can be written as, acceleration can be written as dv by dx times v. Now here I'll introduce v into dv by dx in the place of x. Okay. And what is the value of f? F is 2 Newton. This this dx, what I'll do is I'll transpose this dx to the LHS. So what I get is 2 cos theta into dx is equal to mv dv. And then I will integrate. This is in the variable separable form, right? This is in the variable separable form, and what? And thus can be integrated, right? Since it's in the variable separable form, this can thus be integrated. And while integrating, what do we need? While integrating, what we need is the lower limit of dx and upper limit of dx, dv as well. This is where I said the diagram comes into picture. So as we said that lower limit of x is x equal to 0 and upper limit is x, lower limit of velocity is 0 from rest to velocity till v. Now, which means we can substitute here that lower limit varies from x varying from 0 to x and velocity varying from 0 to v. Now, What is theta? Theta is kx. So cos kx varying from 0 to x and v varying from 0 to v. Now what is the integral of cos x? The integral of cos x is sin x. What is the integral of cos kx? Cos kx integral is sin kx upon k. The whole limit varying from 0 to x. Integral of v is v square by 2 varying from 0 to v. If you apply the limits, what we get is upper limit sin kx, x is replaced by x, minus lower limit x is replaced by 0, so sin 0. What is sin 0? Sin 0 is 0. So this entire term becomes 0. RHS v square by 2 at v is v square by 2 minus at 0 is 0 square by 2. So this term also becomes 0. So basically what we get is 2 into sin kx by k minus sin 0 by 0, which is sin k to 0 by k, which is 0 by k, equal to mb square by 2. This implies 2 by sin. So this implies 2 into sin kx by k is equal to mb square by 2. What is mb square by 2? It is the kinetic energy. And what is kinetic energy given to us as? Given to the question, that kinetic energy is n by k sine theta. So kinetic energy is n by k into sine theta. Now if we compare these two equations, we have kx can now be replaced by, it is given in the question that kx is theta. Kx is theta, and therefore if you compare these two equations, sine theta, e, k, and the only variable is n and 2. So by comparing these two equations, we can say the value of n is equal to 2. Okay. Now we'll do the same question using work energy theorem.